are you?
Yeah, a little bit.
Oh man. It's not done.
Only every other pick.
Okay, I want to do a thing with the center, right? Because I want this to be an outline. I want to do this thing with the center where it comes out, kind of it like follows the fingerboard here, so like the shape of it, right? And then here, I just grabbed one of the air violins from upstairs because Addie said I could. This is not the same size, but you get the idea. That like it comes out here, but then I want to like kind of come back in like with the tailpiece.
So underneath this you want solid? Down on this layer?
Yeah, I want it to be like a complete like solid piece of wood from like obviously this, and then like this too would be part of the same thing.
Yeah, that'll be really good for strength, having a solid piece between here
and then
tailpiece.
I was just hoping I could maybe kind of follow the shape of it rather than having like a straight line down it. I thought it'd be cool to like follow the shape of like the fingerboard and the bridge and stuff.
Yeah, we can do that. I got my small bandsaw blade in, so we do have everything here to actually make one of these from scratch.
Oh.
So that should save you a bundle.
Okay.
So last time I bought one, it was like 60, 70 bucks.
Really, a bridge?
Yeah, because it had the pickup in it.
Oh, because right. Got it.
But you know, I've made them before. They're not too bad. And now we've got a very high accuracy bandsaw blade for actually getting in there and cutting these. So yeah, there's no
unless
problem.
you want one, unless you want to buy it, it's not like it's.
Well, I mean, cheap is good. Maybe cheap, you know.
And we got maple laying around, so.
Okay.
We can
Good
totally
luck,
do
guys.
that.
All right. So this is the Me Arm project.
How did you do it? How did you come about it?
I just kind of ran across it one day when I was searching through Thingiverse, looking at 3D print designs and whatnot. Okay. And ran across this. It's available in acrylic. This one's wood, and I stained it, of course.
Yeah.
Because I'm a woodworker. Powered by Arduino.
Okay.
And then I did a prototyping board on top with a couple of PS2 joysticks. And then they control the position of the arm and the servos through the serial ports on the Arduino, or the analog port.
Cool.
Yeah. So power, serial input, and then the digital pins that you can't see as well.
So what should it be able to do?
Control the arm.
I know, but can you show all the degrees of freedom that it's got?
Possibly. I don't know, it's been malfunctioning on today.
Oh.
Yeah. I just finished this prototype board last night.
Nice.
Which was hard for me because, you know.
Woo!
Yeah.
Oh, cool.
Yeah, it's pretty fast. Right now I've got it slowed down. There's height.
Can you turn left and right?
You know, that's the part that isn't working today.
Oh, the code.
It's not the code. I think it might be my board. I might have a short on the board or something like that. But it's working for extension and height.
That's cool.
And grip. The gripper I might actually replace with an electromagnet at some point. Just for easier lifting metal items.
Sure.
Small metal items. I don't know what its abilities will be for lifting weight, but
oh, fun.
yeah.
Alright, so let me get a close-up then of this.
And the floor is slippery, watch for that. Okay, good talk.
Alright. Grab your finger.
No.
How cool.
Yeah. Oh, something. I wish it was rotating because this thing, if I run it on an automatic program with no delays, I mean, this thing just rocks like that.
Oh, neat.
Yeah, like you,
so it's fat, it's very responsive.
Yeah, and I mean, it's enough to just tip it right over if it's not mounted down to a surface, you know, for an actual production.
And then were these servos specifically for this project?
No.
Or are they just like your junk pile servos?
These are 10-gram servos, and the ones that are normally included if you buy a kit are the 8-gram servos, the blue ones.
Okay. Oh yeah.
Yeah.
So these are better quality.
Yes.
Okay.
And they can move more and they run the same voltage.
Cool.
Yeah.
Nice. And where did you get it cut? Where did you get these pieces cut out?
Let's see. That would be Phenoptics or something like that. Company like that. And they did the laser cutting. This is birch plywood, 1/8 inch.
E.T. phone home.
Back to home. It's a toy.
That's pretty awesome, dude. Welcome to the new shop. There's a siren. What does that mean?
Danger.
In general?
Sure. Not only
Midwesterners at work.
it's only danger for Will Robinson.
Oh. I see. Haha.
Yeah.
Do you want more light?
Because there's a yellow and green one in there that would wire up.
It looks like we're pretty close to what was in here. I mean, the ceiling looks a little bit darker because there's not as much head but on the work surfaces, it looks like yeah,
It looks pretty nice on the work surface.
It's nice and even.
I have one more drive to replace in Waspers data.
Alright, so
Did you notice I messed up my motor today? Accidentally, I was reading about getting.
Oh, we're off.
And I found the command and on some form and ran it with an argument. But apparently that argument only.
I'd be very surprised if it came out.
I feel like it's the kind of thing that cuts out nicely. I feel like it's just going to be a bunch of cut lines and then it's just going to fall apart.
I don't know. We'll see. Prove us wrong.
That's what the glue was for, to make up for it.
Hey, when this explodes, glue it back together.
I apologize.
Yes.
Alright, so basically what that is, because we're not going to plane down multiple of these boards, we want them all identical. We're just going to plane down the one. Now we're going to cut strips out of it to get our 3 pieces. So measure this and make sure we've got more than 3 in that board.
Don't let her start figuring out.
No, I'll do that for her. Got it.
Where are we gonna put this, guys?
Right there. Because I don't think
On the printer?
Okay.
Is it sticky?
no, it's vellum.
Great whisker.
Alright, so this is the joiner, and we've got our piece of wood here that has a cup in it going in this direction. And we need this surface to be flat. Right? So what we have here is a very flat surface that we know is flat. And we have a very flat surface here that we know is flat. And these are coplanar, which means that they are always in the same plane, but one of them can move up and down. And then here we have a spinning head with straight blades on it.
Of doom.
So this thing comes around and cuts material back. So when we're running this guy over, It's sitting flat on this piece, but it's bowed up a bit. And we run it over those blades. And you can see right now it won't go onto that second table. It will when those blades are rolling, because those blades are set up to be the same level as this. So it removes material off the bottom of this so that it can sit flat against this. And that blade is straight. The cup isn't. So it's going to cut here and here, but not necessarily here because that's higher up. So as we run this through, it's actually going to flatten out the bottom of this board. Alright. So I'm going to set this to a very minimal gap because we only want to take up a tiny bit. So that's pretty much set up the way we want it. Now I'm going to run this through, and you are going to move up to the side.
Yeah.
Should I move somewhere too?
I thought you were going to do the rough side.
Everything here is safe.
Okay.
No, that's for the planer.
Oh, okay.
So these are spinning this direction, so if it does catch this piece of wood, the blade is going to push the piece of wood that direction.
And I'm going to hacky sack it off.
So, you know, I'm telling him to move. This is our reference surface, so once I get past the blade, I'm holding it down to this table. I'm not pushing down on the back, causing it to tip.
Close the garage door whisker for the noise.
Nah, it's not that loud. Side is totally flat. Now we get our thickness down. Make sure you keep track of which side is down.
Good point.
That matters.
Alright.
I also have video documentation.
This is not in the right, here, we need it to be the right thing. Millimeters. There we go. Now 18. Oh wait. It's 18.
Okay. So that dropped us by what? Half a millimeter?
Yeah. About half.
Okay, so
I can drop it, that's helpful too. 17.43. Oh, 17.3.
So about.
That's what it is.
So we're getting real close now.
Yep.
So we can sneak up on it.
16.9.
What's the goal?
16.67 is our goal, right?
Does it have to be so precise as that?
No, but we're learning.
Yeah. Precise as possible, right?
I see. So, perfectionist. I get
Of
it.
course, all the way. There's no other way to do it. There it is. It's about 16.6,
That's close enough.
which is really close, so.
Voila!
So now we have an absolute known thickness. We know we're flat on this side, and we know this is parallel to that side, so this is also flat. Next thing we need is to make sure that this is 90 degrees.
And it's not.
So what do? Join it?
Back to the joiner!
Okay.
Yes.
Party!
Mm-hmm.
Love it.
Okay, so this is the surface that we joined flat. We know that this fence surface here is exactly precisely 90 degrees perpendicular to this surface here. So if I place that flat surface that we know is flat up against that fence, I know that as those blades come across the wood, those blades are going to be exactly perpendicular to that face, which means I can create a perfect 90-degree angle on this whole side of the board. Okay?
Good.
That's it?
Yep.
Easy peasy.
And now we want to mark these so that we know which is our known face.
Oh,
Pretty
with
close
the
to where
60.
you have it.
Oh, okay. So like,
'Cause
should
I can
I
see
go
this
the edge of
too.
the blade being at like the 65 then?
Yeah,
kind
it
of?
looks like that's about right to me.
Okay.
Alright, now we want to make sure that that's square. So I'm just going to kick that edge in. So now we know our fence is square. Let's slide it in.
Should I make sure the rail is straight too though with it? The rail popped off a little bit at the edge.
Okay.
There we go. So that's fine.
Okay, we ready to clamp down one side? Okay, this side is clamped. Check your measurement, make sure we didn't knock anything out.
It's on like, okay, like the 66 mark. Is that still okay? Or should I go a little bit further this way then?
Looking at it from
There we go.
it looks like it moved 0.5 millimeter, but for what we're doing,
It's fine. Cool.
definitely not going to affect anything. Alright, so you're clamping this back side here so that it can't turn.
Already watched the tendon about that.
Bam!
Yeah.
Like a pro.
Okay. I'm going to double check and make sure this is
Well, there was a
90
place in
degrees.
Mankato that this one, the thing,
and we're all set up.
at the time I was like 15, and I had a moped, so I drive my moped after you come out.
For those people, those work that's
We are marking which side was our flat side, our
And
original
90
reference
degrees.
side, and which side is known 90.
Yeah.
So on this machine, this is our reference flat, and this is our reference 90. So when this board goes in, I want my flat side against the flat side, and my reference 90 against the reference 90. Alright? All that makes sense?
Yeah.
Okay. Now, for safety, just make sure there's enough to clear there. This keeps that blade from moving side to side, and the wheel behind it keeps it from moving back. So the closer it is, you know, the shorter the distance between, you know, this area and this, the stronger that blade is, and it will not move. Now this blade is ridiculously overkill for what we're doing, but you know.
That's cool.
So I'm just gonna run this through. I need to make sure I can clear out the back, which I can't.
You come closer. This one won't like hurt or anything.
Okay, I can now get out the back. Can't get in.
You're gonna pull it out.
Alright. We are ready to make our first cut. Well, apart from joining and planing.
Bum bum bum.
Thanks. I was thinking about that actually. I was like, okay.
Alright, we ready?
I'm good now.
Yo. Bam.
Alright, I believe that's the piece you want, right?
Yep, that was the side of the. We should still have the wood.
And as it so turns out,
Are they the same almost?
it was exactly half the way that it worked out.
That is funny.
So we
that
don't
is-
actually have to cut
It's
another one.
magical.
The blade width. The magic of blade width.
That's
I used to
beautiful.
calculate to the center and then I go 16th on each side.
Alright, so the one that's next is getting that to the correct length of the
I
violin,
have to go
right?
check to.
But we do need to do some double checking on your design to make sure that we have the extra where we need it and whatnot. So these are our known pieces, and they are milled to perfection at this point. Other than these ends, we don't know if they're 90 degrees or not, but that's what that's for. So here's these. And let's go take another look at your design and make sure we know what we're doing before we cut. Degrees this way, and this is 90 degrees to the blade. So to create a 90 degrees on our end, I can go flat against this, back against this, and anywhere that the blade will cross it, and that will cut this to perfectly 90. Okay? Alright,
Step back.
yeah, back by the camera.
Okay.
I'm a point of reference at this point. Good
Alright.
job, Whisker.
Now we've got a 90-degree end, so we can measure our actual length to make the cut.
Okay.
And
Give us a
I
feedback.
can't remember numbers, so
14 to 5. But I'm gonna check now because now I'm
That was right. You were correct.
What you? I am. You know that? You know that?
Yeah.
3, 4, 5. Okay, and you learned about kerf on there. The width of the blade removes material, so that material doesn't exist after you cut. Same thing with this blade. We know what the kerf is, but if I look at this hole I know where that curve ends because that was cut with that blade. So if I line my line up with that edge, I know
That's what it's gonna be.
that's what's going to be left. Okay, make sense?
Yes.
Everybody ready?
You. All match?
All match.
Nice. Well done. Well done, you guys. Very fun. You got something. You got fancy stuff.
House vacuum in here, it was that clean.
That's why you do.
You do.
Which is basically a normal pipe processor. IMX 6 arm, Cortex A9,
Yeah.
with a which is not the same as Arduino GUI.
Okay. So show it. Let's see. There's.
So this thing right here is the Arduino part, based on this chip right here.
You know you've got magic powers when
Cool.
you use
And then let's look at the actual
And-
thing.
Our HDMI happens to be the projector,
Okay. Very nice.
but
It's this little bitty thing.
this is a little bitty thing.
Oh, cool. So what can you do? Can you like surf the web and all that?
You can surf the web, you can make it do outputs. Like if you wanted it to light up certain things when you went to certain pages.
Oh, nice.
But when the rabbit hole is being accessed, you could say, all right, tell me I'm being accessed.
Oh, handy. Okay.
You know?
So like a
We,
notification
we could
box.
set it up so that it could run motors.
Fun.
For like the RoboJet.